Okay, so welcome on my presentation. Like Barry said, my name is Dominik, and in this talk, actually, I would like you to taste the future with web component technology. And the main goal of this presentation is to show you a new and unique way to create web components. So let's get started. First of all, I have to answer on the question, what are web components? So can you raise a hand if you know what are web components? Cool. So like a half of audience. So actually, I will tell you more about this in short. So it's not one thing that will be available in your web browser just like this. It's not one thing. It's actually a group of specifications, APIs, that allows developer to extend HTML and create own custom new elements. And the whole idea is allowed to them work as the same as the built-in elements. So it's required to add features that actually those elements have. So we have custom elements API, which allows to create those elements, shadow DOM to create internal DOM structure, HTML elements, HTML templates, sorry, and originally there was also HTML imports, which was changed to ES modules. So what about the support? Is it the future or now? Actually, like you can see in this table, almost all modern browsers supports web components already today. And what is worth mentioning, Firefox released a 63rd version a few days ago with native support for custom elements and shadow DOM. Moreover, a few weeks ago, Edge team announced that they have started developing those specifications. Yeah, finally, we can say. So how we can create web components? Of course, we can use the platform, but I think it's useful for creating very simple custom elements because those old specifications are very low. So we had to create a lot of code to create more custom elements that have more features. So here we have a few examples of libraries which allow to create those elements. Actually, there is, of course, more of them, but these are for sure the ones that I will recommend to try. But actually, why I put them here is more because there are some common between them. And actually, not only the libraries that were created to create web components. So what is the common thing between them? They all share some common patterns. They usually use a class syntax, which can be confusing, especially this and how it works in binding functions and other things. Lifecycle methods are usually misused or not very well understood, and you have to read a lot of documentation to understand how it works. And finally, this is stateful architecture, which means that your objects are mutating, and the state of the component usually is a result of some sequence of steps. So there is a simple question: can we do it simpler? And actually, I would like to propose the solution for that. So we will start with the low implementation, which we can use with Custom Elements API. So what we can see here is that we have class syntax, of course. And actually, Custom Elements API requires to use classes. And for this example and the process which I will show, it's not kind of the live example of using Custom Elements API, actually more to show you what kind of features the class syntax has. So we can create computed property. I think usually you don't use this pattern, but it's possible to create computed property, which means that you can access this like instance.text in this particular example, but actually it will call the function to return its value. And we also have a setter which actually saves this value to some other variable. And of course, we can use methods. So it's kind of the simple thing. But actually, what are the classes? Do JavaScript has classes? No, of course not. It's just the sugar. So what we can do is just the sugar. And actually, I think it's more complicated. It was on the screen before. But stay tuned. It will be better. But actually, what we can do here is to use actually thing that was already there from the years. So after the hood, the classes are just functions and prototypes. So instead of creating things inside of the class definition, we can actually put it outside of that and use define property and create those properties on the prototype. So this all properties from before slides, we can switch to prototype. So we are defining property with get and set method. And also to actually have the same pattern for both things, I used also a getter here. So maybe it's some kind of confusing because I could just write value and put the function. But for the purpose of this process, I put it in the getter. And it works like the same. So the last line, which I not covered on the first slide, is like the custom elements API that actually allow to define that element. So it doesn't change. It will work. So what we can do next? So like you could see, there was a lot of redundant code. So we can hide it to our custom definition. So instead of creating those define property, we can hide it into our own implementation. So for now, we are more thinking about our custom element definition as a plain object with a map of properties. So the descriptors of the defined property, actually, we are putting in the definition of just key and values. So it's a foundation of JavaScript object-oriented things. Like we have just plain object, keys, and values. So those keys are the names of those properties, and descriptors, of course, are just values of them. So we are creating our own defined element method, which is a custom function which creates those class on the first line before, applies those descriptors, and define custom elements. And actually, the fun part starts here. Because if we have all control over the custom define element function, we can do really funny things. The first thing is that we can get rid of this. We don't want this. Because this is confusing, we have to use function, we can use arrow functions, destructuring. So what you can see here, our example is shrinking. Because for now, we are using this as the first argument of the getter and setter. Because we can. We can define property with our function, which actually there will call these methods. So we can just switch and use the instance of this element as the first argument. So you can see that we are using destructuring. And also, we can use arrow functions because the context is no longer required. But I didn't mention about how the getter was really confusing here, because the getters and setters doesn't allow to keep the value. So they require the other variable which holds the data of the getter or setter. So there was a trick that we created underscore text property of the instance and holds them new data. So at the default, we had the text which is ConFrontJS. But actually, if we want to create a different value for this text, we have to hold it somewhere. So again, because we have custom definition, we can do something more tricky things, like add middleware to save those property values. So for now, set method actually not creating a new value for some other property, just return it. And our custom definition will hold this value. So like you can see, it's really clear here that we also can, from now, we can using another feature of JavaScript, like default values of arguments. So for now, you're just, we tell that the getter, which can take the second argument as last value. So it can have a default value to ConFrontJS or just return it the value which setter set. OK, so that was middleware. And how you can see, maybe we can ask our question to us that what about creating another text which is different property but behave the same? So we would have to create another property which is actually pretty the same, but the default value is different. So we can add and introduce the property factory. What is that? It's just a function which returns dynamically a property definition. So instead of creating each time the object of the descriptor, we can create the function which will create for us this descriptor. So in this slide, you can see that also we can use this factory again for another property. So for now, we can create other text, which default value will be, it's super cool, but it works like the same as the text property. And the last step is something mind-blowing, maybe. It's a property translation. So again, we have a custom definition. And we said that our custom definition takes object with keys and descriptors. So what would happen if our custom definition would take something different, like string, like function, or even object without get and set methods? So we can translate it. So instead of using, again, factories to create properties, which are very usual, we can just say that if our key is just a string value, we will translate it to pre-filled property factory, which will our custom definitions knows. And there can be other rules, like if you just want to create a computed property with get, you just actually could just set this key as the function. And then this custom code will translate it to actually descriptor with the get. So that's the process of the syntax. I hope that you understand it. So the complete definition syntax can be like from something that is really classes, this, and other things to really short. Like you can see, actually our element definition is just 2 lines. We want to say that we have text, which is default value ConFrontJS, and we have some methods. So I think you may notice there's something missing here. And usually you are using those things very often. What about lifecycles? I didn't mention how it could work. I said that we can just define default values, but what then? How it will work in DOM and cooperate with different elements? So of course, I would not ask this question if I would not have answer. So I would like to show you the simplified component lifecycle. If you really think of this, what you really need in the context of components, actually it can be really simplified. Of course, there are 2 lifecycle callbacks which are required, which are connect and disconnect. And I think it's obvious that we need them, because sometimes you have to call something when the component is mounted, and something should be cleaned up when it's disconnected, unmounted, what you say in the context of framework which you use. But what is inside of this gray box is actually really different. So I would like to propose a different concept. So actually, usually is that your component is mounted, you change the state of this component, and this requires render. So the render is the effect, not the cause. So I would say that rather than thinking about what happens when, actually we would like to just say that we want to render the actual state of our component. So we are not starting with those life cycles. We are starting just to render thing to the DOM, or something different solution. And then this render method requires the actual state. So that's the flow. The render requires the calculation of things, even if they are asynchronous. So we don't have to actually, and when component is mounted, call our APIs to fetch the data, because the render, which actually said, hey, I need this data, so fetch them for me. Of course, there are also side effects, but I would not cover them very much here, because I would have to say about different aspects of this problem. And the time is short, really. So I will focus on these 2. So how we can do it? Actually, to create those things, we have to think really differently about lifecycles. So we have cache mechanism and change detection. And of course, about connect, disconnect, we can use the custom elements API, which is already here. So we can call connected callback and disconnected callback from custom elements. So what is about the cache, and why I mean cache? What is the cache with lifecycles, even though? So I propose here to more live example of the component. So we can say that we have GitHub stars element, which takes user repo, takes the stars, which is actually some asynchronous call to get GitHub stars somewhere from, using this user in repo, and we have some render thing. So don't bother about render, but actually this will be something that will update the DOM. So like you can see, render requires stars property. So this is actually the structuring. So if you call something like this, the code actually will call stars. So we already know that our properties are not just the values, are getters and setters. And the second thing, we know that we created middleware which holds the data of these getters and setters. So actually, does this middleware can be something extended, not just taking value and returning? And yes, it can be just complex cache mechanism. So actually, it's not like that this getter is called by the way. It's actually the cache that calls it. So the cache calls setter getter, which actually requires user and repo properties. So we have like recursion here, something like that. That cache, again, have to, inside of this function, calls user and repo getters. So what we can do, because the JavaScript is single-threaded synchronous code execution in the event loop, we can actually know that the stars depends on the user and repo. So we save them as the dependencies of the stars getter. And of course, when there is a first call to cache, the cache returns stars getter result, which is obvious, which can be, for example, the promise. But what happens in sequential render is more important now. So even though it would not be called if user and repo doesn't change, we can, for this actually the slide said that there is another dependency that requires render. So render requires, of course, stars property again. But what happens next is different. So if cache holds the data of stars, it will check if the dependencies, user and repo, cache state has changed. So there are, of course, two answers. Yes, so if they change, the cache clears all the dependencies, call stars getter again, and the process begins like in the first one. So the cache will save new dependencies and returns new result. But what happened when the cache says that repo and user doesn't change? So the cache would say, OK, I can just return the last value. So like you can see here, we don't even need like lifecycle methods like will props will change or component did update and then check if one prop is changed and that prop was changed and should I call this method or not. We can think about the components like the streaming of data which actually wants to create our render, our component in the DOM. So we don't have to actually think about it when something has changed, because if it does, it will render things properly. So I was talking about the changes. So there is one missing thing here yet. What about change detection? Because actually, if the component will have different user value, we have to render. So let's say that user or repo property is changed. So we know that next call to stars will return new value. It's not like immediately we'll call stars. So there is a lateness in this concept as a foundation. So we have to say that in this concept, we have some factory. You already know what is a factory. So this render factory would return our descriptor, but actually could also render things to DOM using some kind of the function. So this thing has to be notified about stars in validation. So what we can do, actually we can also use the platform. You have events for that. So in this concept, every change, and actually change in the cache sense, not just calling setters or getters, would dispatch the invalidate event on the host. So our render factory could connect to this event, and when it occurs, it could call re-render. So I said about connecting is connecting. So what about those two callbacks that I said we are actually needed? So this is actually super simple. We can just add it to our property definition. But what is meaningful here, we don't create global lifecycle. So it's not in the sense of your global component that you have to put all the things that you want to do. It's independent. So every property has own connect method, and it can return this connect method. Of course, this is usual pattern in functional programming. So it's like you can have access to your local variables, and you can just clean up code very easily about what you do in the connect. And the third argument of this function is also very meaningful because it actually allows to connect every single third-party library that you want. So for example, you can actually very easily create Redux connected properties in this concept. So I would like to say that it's already here. This concept, actually what I wanted to show you, is a library that I created over the last year and published in May as a major version. So you can download it today and have fun with this concept. So I would like to also say what are key features of this library. Of course, there is no class in this syntax. Also, it's really easy, which I not really covered, but if you then think that properties are independent, you can easily reuse them, merge them, and split through definitions. So it's ultimate composition here. You don't have to apply extends on the classes or other patterns. There are also no global lifecycle callbacks because actually we don't need them. Only the connect and disconnect can really provide you all the features that you need. It's also the super fast value recalculation because actually even the render, it's just a property. So if this dependencies of render doesn't change, the render doesn't have to be done. There are also 2 points that I couldn't cover here. This library also has a template engine based on tagged template literals, which is really fun, and have some really unique ideas there. And also, I wanted the library to really be good for developers. So I think it's the first library which allows to hot modular replacement in dev mode for creating custom elements. So you may ask, can we see it now? Do you want to see it now? Yes. OK. I have like 2 minutes to 25. So. Or we have questions, or the demo will be longer. So we will create this GitHub stars element with hybrids, like you can see here. So this is a super simple HTML code, which has only this source JavaScript, and we have some styling for this purpose of this demo. So we have already here these all elements. And I'm using super fancy new features of DevTools. So you can see that they all now have stars or repo property or something. So what we have to do, so what I said before, we just create our GitHub stars. And we can just start with things like user and say that our default would be just empty string and repository. And of course, what we have to do is define that. So we say that this is GitHub stars. Oh, sorry. So, OK. Voila. So like you can see, the page doesn't reload, but the code changed. So for now, we have fully working custom element that has property. Thank you. This was for applause. So that's the question. If you do want to more demo or have some questions. Demo here. OK. It's likely 2 or 3 minutes. So we started with this, but actually we want to render something. So like I said, this was not covered by the presentation.
I knew that you would be the guy with the gong.
Yeah.
I knew it, Dominik.
Thank you, Barry. OK, so we can say we can use, like said, that this is our repository, and say that we don't know how much stars he has. OK. So when we refresh, the render caused the re-render of our custom element, so we can see that this is already here. So we have fully rendered components. So if you don't believe me, I can just change the user to ISD, whatever, and it will change our render. We'll go back to Polymer, of course. User. Oh, yeah, maybe some other else. Yeah, thanks. But next time. So the most thing that we would like to cover is our async API, of course. So our stars actually are exactly the same object here. And actually, we'll show you something funny. This is actually normal function which just takes the same arguments. Of course, this is not a coincidence. So what we can do, we can just put it like this. So you're just using the function which is not connected at all to component system at all. It's just the function. We can save it, and nothing happened because the render doesn't change. But if we take the stars and put it here, so what is the most important here? There's no network now. You can see that if I'm not using the stars, the API doesn't call. So if I have an internet connection now, which I suppose I have, it will work. So let's save it. OK, so we have promises. So that's not all. Of course, we want to show the stars count. So I will not also cover that, but this library also works with promises. So we can just say stars, then count, and create our count as a nested template. And I think I missed something. Yeah, I think here. Voila. So we have fully working custom elements with GitHub stars. So the last thing that I wanted to show you that this concept, no, just 1 minute more. Please, the second gong will be in 5 minutes, I think. So we create a button when on click will change our I'm not so fast. Counter, 1, blah. No, I know. Oh, counter, yes, of course. So you're not sleeping, not yet. And let's say we want this counter here, which I will add in the moment. So like you can see, this is the native thing of the platform, and actually it allows to this iceland thing. So what I wanted to show you, blah, blah, blah. It should work. It's always this always that doesn't work as supposed to be on live demos. You see, I would just, what? It doesn't work. Okay, I don't have more time. Oh. No, this is count. This is okay.
Up, down, over.
Yeah. So, okay, that's my mistake. Sorry, but despite the fact that it doesn't work, I wanted to show you that that the network would not be called if we change something different in the component. So, thank you very much.